Good afternoon, everybody. I think this is the session which is like post-lunch, last session, as I'm sure everybody wants to be getting out of this place. We'll try to make it as short as possible and also as interesting as possible so that, nobody dozes off, and already strength is very small. Yeah? Right, Andrew? Me and Andrew are here to introduce you to a new technology which we think is for our next water and wastewater sector. As our chair was mentioning today, and also in this morning, Ma'am Sunita was mentioning about, in India over decades, we do have a lot of technologies, and then we've been there is a lot of improvisations over the technologies, but mostly they are conventional or they are either centralized. I think it's time for us to move on and look and explore the new technologies which are available. When we were discussing in the morning, Andrew, we were saying there are countries like Australia, Singapore are 10 years ahead of us in terms of technology. Why can't we have one of those? Yes, there are certain proven technologies available. We are working with them. We are good to go. But I think it's time for us to move on and look for it. Speaking of Enzen, we are a group of knowledge practitioners and who believe in looking what is next in the industry and in the sector. We always believe in answering how to do it rather than answering what. Okay, moving on to the presentation. The simple facts in our wastewater industry is only less than 30% of wastewater is getting treated isn't it astonishing? Where is this rest of the 70% is going? The numbers are between 26 to 30%, taking an average of 30%. Where is this 70% going? I'm from Bangalore. Maybe around 10, 15 years back, we had close to 100 plus lakes. We don't have them anymore. And how many rivers are healthy now? And referring to my previous speakers, so many rivers are dying, and I think it's time for us to look at the new things around. And other aspects of this thing is there are huge outbreaks happening. And where is this coming from? Is that our treatment technologies are not efficient? No, we do have it. But only thing is, we treat them either we cannot accept the fact that we are inefficient, but the thing is by the time they reach the consumers, either it is getting recontaminated or they are not getting a right quality of water. So, talking about centralized treatment plan or centralized treatment methods, what we are been following from over the decades, major spending is either for transmitting the water to get it treated, and or collecting in terms of wastewater. It's for the collecting the complete to treat the wastewater. And there are a lot of issues with the centralized treatment, and then we have to get over as we were discussing. There's a huge energy cost associated with that. There is a non-revenue water, unaccounted water, everything. So, looking at the recent developments, Niti Aayog also is aggressively promoting the decentralization of wastewater treatment, and Rural Water Supply Department is also talking about treatment plants for the villages. So there are multiple technologies available even in terms of decentralized treatment plant. Why is that we don't have the success rate what we are looking for? The reasons are listed there. I think it's we do have it, and either it is because of the high cost of operations, and also either if it is because of the quantity and quality of the wastewater which is coming into the system, and by the time you have somebody to fix it, either it is inefficient or it's not up to the mark what it is needed. So I think it's the time for us to come up with a technology which has the lowest failure rate, highest efficiency, and also it is low cost in terms of what we have to handle it. With the technologies what we were looking, we were at Enzen, we believe in bringing the technologies which is globally best and then the very practiced one. One of the technology, what we believe, and then we have been working with the Australian firm Micromet, and those are the ones which align with our Enzen's vision of providing and making water accessible at the affordable, and then the technology which is sustainable. So with that, I would like to invite Mr. Andrew, who's our technology partner, who would give you the more details on the wastewater treatment technology.
Thank you very much, Chethana. It was excellent. Also, I'd like to briefly thank the Aqua Foundation for putting on this event and being such gracious hosts. This is my first time in India, and it's a great pleasure to be here to speak with you all. The weight of responsibility sits on all of our shoulders. Why should children drink water that is not healthy? Why should their parents? The technology's out there, and as they always say, a revolution comes without a warning. And what Enzen has done in bringing us over here is to try and bring the revolution that Australian industry has brought to water. My home state, South Australia, is the driest state in the driest continent on the planet. So we have had to face these challenges for many, many years. And it's a great pleasure. This is the first time in India that we've spoken about this technology. And it's a great pleasure to be the one that gets to come and present it to you guys today. Now, just get some advice on how to...
No,
just that guy?
Sure.
Perfect. Lovely. Sorry, guys. Okay, so basically what we do is a little variation on electrolysis. So we can basically take very, very average waters. We've treated radioactive waters, we've treated high arsenic waters, heavy metals, fats, oils, grease, bacteria, etc. Harmful compounds in waters, but with the Alchemax machinery that we're proposing to bring to India in conjunction with Enzen, these challenges are really solved. And as many of the speakers today have said, the technology's out there. It's about how do we deploy it, how do we fund it, budget it, and get it out there and working for the community. Just very briefly on a technical front, you'll see this one is, this diagram has a picture of a factory, but that could well be municipal waste or sewage as well. Basically, the Micromet Alchemax system, we pH correct, we put it through our reaction chamber. Now we're talking, guys, about per electrode 0.25, that's 0.25 kilowatt hours per 1,000 litres, which is an incredible figure for those of you in the water industry. We're also talking a small footprint, so a 40-foot shipping container, we can do a meg a day, 1 million litres a day, to a very high level. We then filter it because, of course, electroflocculation, we're flocculating things that were in solution into something that we can filter out. And as you can see from these cups here, the process, as it goes through, the water improves at each stage of the process until finally you have the water there on the right. What it means is quicker treatment cycles, and it's continuous flow. You're not having to batch, so you are providing a constant flow of water. As I've mentioned, it's a small footprint, but it's worth talking about the modularity. So if you have a small village, we can just put one module in at 2 litres a second. If you have a massive city, as Chethana alluded to, and as many of the other speakers have alluded to, with the decentralisation model, instead of having to put vast pipe work and billions of dollars of infrastructure under the ground, we can actually locate in point of source, as we call it, and actually treat the water at the point of pollution. Now, because it's modular, we can then join those modules together to create pretty much as large or as small a system as required for that job. So it's a very flexible system. In fact, this picture here is of one of our demonstration machines. So we can literally put a shipping container on the ground, plug it into power, bring the water in, push the green button, as they say, and we're off and racing. One of the things that we find is different from the biological systems is simply the fact that we're not susceptible to a lot of the variables. Now, we're not saying that biological systems are bad systems. We're not saying that any of the normal technologies that have been used right around the world are bad systems. They're good systems. They have their various different challenges. Some require higher maintenance, others are a higher cost. What we think that this system does is it gives a very robust answer to those challenges, and particularly if you look at, say, chemicals. Occasionally agricultural chemicals may find their ways into the sewer. In a biological system, that can knock out your bacteria, and all of a sudden you're discharging untreated waste. We don't have any of those type of issues. It also means that a very low skill level can be brought to bear to run the units. You don't necessarily need a highly qualified engineer. And what we do is we don't just sell a product, we sell an entire solution. So we have some university courses that range from a very basic 3-day operators course right through to someone who could build one of the units from scratch, which we call a Technical 2 course. So when we put these, when we deploy these machines, what comes with it is a system. It comes with training, comes with support, and it means that we're not going to get to a point where we've let anyone down through the machine not operating properly or failing due to a lack of maintenance, which really, when you think about it, the technology is one thing, but actually having systems to support that technology so it works year after year after year, that is equally important. Having a lower power signature is very, very important as well. It means in rural communities where power may be intermittent that we can operate very effectively. We can also use wind and solar power, which helps to reduce the air pollution, so we're sort of killing two birds with one stone. I should also mention the telemetry. We can monitor these machines remotely. Now, what you see here is one of our Generation 2 machines, and you can see the tanks in there. Each tank has an electrode, and the water makes its way through a series of iron and aluminium electrodes which flocculate out different elements as the water goes through. I've mentioned that we're a bit more reliable in terms of contamination compared to a bacterial system, but we're also a much smaller footprint and a much cheaper and quicker installation. So it means that governments and policy makers have a lot more flexibility in the decisions they want to make. Where do they want to locate these units? They don't have to look for a massive site and a massive bit of land. They don't have to put in huge capital pipework infrastructures. It gives policymakers and government departments charged with the responsibility of delivering this water the ultimate flexibility in where we put resources and how we deploy them and how quickly we can roll them out, as opposed to, say, a large dam pond treatment system, which can take months and months and months, if not years, to commission. We can commission one of these sites very, very quickly. Now, again, we are strong supporters of anyone who is treating water, so we are not suggesting for a moment that any of these are bad technologies, but they each have their ups and downs. In partnership with Department of State Development and the Water Industry Alliance of Australia, we commissioned a study done by an independent company to basically identify what were the main competitors, if you like, or alternative technologies. And the important thing was to come down to the cost and the power usage, etc. So what came out of that was the combination of easy deployment, reliable running and scheduled maintenance meant that our dollars per litre were literally logarithmically lower than the next technologies. So that's why we call it a revolution. It changes your options and it changes the way that you can react to some of these problems. Just to recap, we're talking about low maintenance, we're talking about a very high variation tolerance, the small footprint I've mentioned, reduced human dependence, and the remote monitoring in a country the size of India. really does help. It allows you to monitor the systems, deploy people out where the system is for some reason not working optimally, and allows you to be very, very, we like to use the word nimble. It allows you to be very nimble in reacting to the challenges that are presented to you. Self-cleaning, of course, and that is the breakthrough. You guys who have been in the industry for a long time will know that other companies have tried electrolysis. The breakthrough that we made was actually in the electrical control system of that electrolysis, which prevents scale, rust, and what scientists would call passivation of the electrodes. That is the world breakthrough, and that is our protected, patented technology, which allows us to put these units out and know they're going to work effectively. We can do a number of different treatment levels with very few smells or odours, and again, so topical here in India, a low energy requirement, probably one of the lowest in the field. Couple of quick case studies for you, and I find this Canadian one really, really interesting. In Canada, they've got lots of space, and what they used to do is basically dig a big lagoon a couple of kilometres downwind of a settlement and just discharge untreated effluent into that lagoon. Of course, it would freeze over, no oxygen would get in, the biological process would stop. Come the spring thaw, you've got a hell of a mess on your hands. There are around 1,800 communities who are adopting our system in Canada, and what that's doing is giving them a really good solution. Okay, very quickly, China is getting on board. They've got some pretty big challenges in China, and their regulation is driving that. I think this is the last one here in South Australia, or over in South Australia where I'm from, where they've got already sewage treatment plants, but the capacity is being exceeded. And you can pop one of our 40-foot containers in there and add another meg a day without needing to procure more land. So really, and that's a testimonial of one of our local councils, and you can all read that. So it's been a great pleasure to come over to India, and a great pleasure. I'm very humbled with some of the other presenters who are doing absolutely amazing work. So thank you all very much.